use the filter with that.
To be fair, you'll see Eric's for sure on the wire. Nice and nice.
Rocket ship, taken to the sky.
folks, here in Mesquite, Texas. It is incredible. The skies have cleared up a little bit. The clouds have parted just in time for, we have 3-4 minutes left to totality. Everyone around us have quieted down. All of the solar eclipse glasses are on faces. We're just here waiting. We are waiting for the moment. I think we'll actually get to experience this. It is so close. We have 2 minutes left. Now is the time. If you can, start looking down on the ground. If you're experiencing totality, notice what the shadow bandings look like. We've got clouds peeking through, but you never know. You never know if you'll get the chance to experience the weird shadow patterns. Take a look at trees near you as totality is closing in. It's almost time, you guys. This is incredible. It's just slivers of the sun. And just in time, peeking behind the clouds. There is still a bit of cloud cover here, and it just so happens this one cloud is just choosing to obscure a little bit of the sun, but it keeps peeking through, which adds to so much excitement on the ground. I gotta say, this is kind of reminding me of the final moments of the Super Bowl here. Just the tension is palpable. People are just waiting on edge to see and experience totality if it can happen. But the fact that through the clouds and despite the weather forecasts, we are experiencing this, it is something else, you guys. We are moments away from totality here in Mesquite, Texas. Everyone is just looking straight up. If you happen to be looking on the screen at everybody else who's wearing reds, blues, greens, and colorful clothes, now is the time to notice the Purkinje effect. When colors are just changing, the temperature here on the ground is much cooler. All of a sudden, we are seeing the tiniest sliver of the sun peeking behind the moon. I am actually getting emotional, you guys. This is incredible. Five, four, three, two, one.
Love the hotel, but need more info? Just ask Gemini in Chrome.
Together, Cameras are up. Everybody's looking up, just experiencing this together. There are children, there are grandparents here all together. I am emotional. I can see a planet on the sky. I am crying and I can't help it, you guys. This is phenomenal. I wish Laura, our VJ behind us, could actually take a look, because you gotta come out from behind the camera, Laura, please. But we can see a planet just to the side, and even though it's peeking straight behind the clouds, we are seeing it so clearly. We are lucky that we had high clouds here today, just as this moment. It's absolutely darkness out here. It is incredible. There are folks taking photos with their cameras. They're not really going to get the ideal thing, but like now during totality, I mean, we're going to get 4 whole minutes of this, 4 minutes and 8 seconds. People can take selfies safely just at this moment of totality. And it is incredible. Like the solar activity right now is near its peak, and just from the ground, we are seeing how powerful the corona is peeking through from behind the moon. It is just something else, you guys. And I gotta say, for all of the drama of the weather forecast today, the clouds have made it absolutely spectacular. It's just something else. I hope you all get a chance to experience it at home in the future, if you're lucky enough to afford it, for it to come to you directly. But it is just nothing I've ever experienced before. Yeah, let me grab somebody. Hold on. We're gonna try and get an interview with people out here because this is something else, you guys. So we're just waiting to see if we can chat with somebody briefly. Right now, I'm looking around. It is darkness. It is so cool. The temperature has definitely dropped. We're not hearing much when it comes to crickets or anything. There weren't a lot of bugs near us, probably because it's so busy. But oh my gosh. And we have someone here joining us who is part of Totality and, smartly enough, wore green against my red, so you can see and test out the Purkinje effect for yourself. Please tell me your name.
Melody?
Melody, and where were you coming from? Are you a local? Or?
No, Oklahoma City.
Oklahoma City. How is this experience for you?
This is very exciting. My husband went to the one that was in Kansas. Yeah. I didn't go, so I came with him this time, and it's once in a lifetime kind of thing. It's very different than what I had anticipated.
Yeah. Anything that stood out for you right now in this moment? I mean, the clouds are just in and out all day.
That made it more of a community thing. We were all cheering for the clouds to move, and every time there was a gap in the clouds, there was a cheer. But just when it got to totality, it was very, it was awe-inspiring. Just the ring around it and how it kind of had gaseous features around it. It was just very interesting.
Was it anything like you expected? How is it different from what other people have told you about it?
I had the correct expectation as far as when the eclipse was occurring, but the actual total eclipse, that was different for me. I hadn't anticipated the ring and the gaseous effect of the ring around it.
The corona, the sun's corona. Tell me your name one more time.
Melody.
Melody, thank you so much, and please keep enjoying the rest of our 2 minutes. It's already peeking out. Folks, it looks like the diamond effect might be coming through, or there's a little bit of light. It's a little confusing because of the cloud cover, but it's starting to get bright. You can see the difference right now in the light. It's just complete darkness earlier. It just felt like it was nighttime. And even with the clouds, you still feel it. And so, for everyone else still waiting for the totality to come to them, hold out hope. It could still be this good. Can I interview you? We've got one more person to interview here. Who's a worker? Are we good? All right. Tell me your name.
I'm Brittany Huereca.
Brittany, welcome, and tell us how are you feeling right now?
I'm feeling super, I mean, this is cool. Like, I have no words. Honestly, I've never seen this before. Like, I've never experienced an eclipse before. And the fact that I'm working and I am able to be out here and with my family and, you know, actually getting to see this in person, it's crazy. Yes, like I couldn't miss out on this.
How long did you know that this was happening? You're from Texas. You're from Mesquite.
I'm from Mesquite. Yes, well, I'm from Dallas. I actually went to school here in Mesquite. So I didn't know that, you know, Mesquite was going to be one of the best views of the eclipse from the whole. I was just like, oh my God, I can't believe it. And then I saw that people were traveling out here, and I'm like, dang, like. I've never expected this to happen in Mesquite, you know, because we're a small town. I mean, we're growing, right? But like, we're a small town outside of Dallas. And I mean, it's crazy. We had people come out and get coffee, and they're like, yeah, we're from the UK. Like, people were coming from all over, like, just to see the eclipse.
So how did you feel emotionally at that moment of totality?
I felt like this was so, I mean, I had my kids with me, so then I was like, hey guys, like, look up. And then they were like, wow, this actually exists. Like, we see it on the books, we see it, you know, and TV and everything, but we never see it live. So that was crazy. Like, I felt, yeah, that's God's creation. I love it. I love it. Yes.
What's your name?
Jose.
Spanish.
Spanish, yes.
¿Y qué tal? ¿Cómo fue?
No.
You get a sunburn if you sit out in the sun too long. So imagine looking directly at the sun with your eyes and the damage that it can do to your retinas. And it's not even something that you'll notice right away. It may be something that you notice a day or two later that you sunburned your eyes.
Okay. All right. Well, thank you so much, Julie, for joining us. We really appreciate it. And now I think we're going to throw it back to the views in Mazatlan and maybe or elsewhere around the country. So.
¿Son turistas de Colombia?
Yo de aquí de Mazatlán, soy locutora de
Ustedes son los turistas de Colombia, ¿verdad?
No, yo no soy turista de Colombia.
Tú eres la colombiana. Después te voy a hacer una pregunta.
As children grow into teenagers, many grow curious and engage in increasingly risk-taking behaviors. Some
estrella! ¡Es un planeta! ¿Lo vieron? ¡Otro más! ¡A la izquierda! Miren al horizonte. Vean cómo parece que amanece y todo el horizonte está iluminado.
Bueno, a vos.
Oye, Karen, ese puntico...
15 segundos para el fin de la totalidad. Hay que dejar de mirar cuando yo les dé la señal.
Una pequeña mordidita, y el puntito ya se está desplazando y empieza a verse el anillo de fuego.
¡Se acaba la totalidad!
Nos colocamos los lentes, los visores, ya no es seguro observar el sol.
Ok, ahora continúa la segunda parcialidad. De aquí y hasta las 12:32 vamos a tener el fenómeno inverso. La luna se va a ir retirando hasta que a las 12:32 volvamos a tener el mismo sol de todos los días, el eclipse haya terminado y tengamos que esperar otros 3 siglos para volver a presenciar esto. Muchas gracias a todos.
you know, the eclipse touching down on Mazatlan all day today, this morning. Just the earliest forecasts were cloudy and potentially rainy, and just then you could see just how quickly the weather changes, you know, just in time for that moment of totality. And even after totality, that moment when you know, the diamond effect came in through, the Bailey's beads were peeking through, like, it just is so exciting, and I am living vicariously through them right now as the clouds start to cast a shadow on us instead of the moon. But you know what? There's just so much more excitement to be had, because we're gonna head over to Carbondale, Illinois. Again, the weather's been so changeable throughout the path of totality, but sometimes, look, you just never know, right? Total solar eclipses happen every few years or so, especially like where you know, it's usually on somewhere else like the South Pacific. So this is a really special thing that we are hitting so many people around this North America, this continent. So you know what? We're gonna head over to hear more from a citizen scientist setting up their solar eclipse experiments out in Carbondale, Illinois. Let's take a look.
All my friends sleep on a purple mattress now. It's the only
Broadcasting Initiative, and it's a joint venture between NASA and Southern Illinois University here in Carbondale, Illinois.
And what is your role in the study? What are you doing as a citizen scientist?
Well, you said it. I'm a citizen scientist. I was recruited. I'm an alumni here from Southern Illinois University, and they contacted me prior to the annular eclipse, which we had last October, and asked me to record that from my home in Santa Fe, New Mexico. I kept the equipment, and then they asked if I might join them here in Carbondale. So I drove 2.5 days from Santa Fe and ended up here with all of this gear that you see in front of me.
Borja. Cambio. Espera, aguántame un segundo. Está un poquito oscuro. Vale, va. Bien. Cambio. Sí, cambio. No lo tengo bien, ¿eh? Bien. Aguanta un segundo, Guille. Voy. Segundo. Cuando quieras, Guille. Sí.
Your dinner performance begins early. Spin after
A ver esa nube si se va.
Espera, Guille, te doy plano un segundo. Sí. Guille, ¿te puedo dar un poco más abierto de playa o volvemos a los... Lo dejamos ahí, ¿vale? Venga, ahí lo dejamos un rato, ok. No, no.
¿A la altura de la nube o por debajo? Sí, pero la altura, ¿crees que va a llegar a la altura de la nube un poquito más para andar, no? Eso es suerte que la nube no lo pone. Claro. Sí, venga.
usa el tiempo con eso un poco.
Pregúntale allí al compañero que... ¿Cómo te lo explicaría yo? ¿Cómo te lo voy a explicar yo? Cuando se la llevas que no puede dormir. A mí no me llama.
Sí. Hasta luego. Chao, venga, gracias.
Cheap flights, insane hotel. Skyscanner really delivered.
Remember all that crazy stuff we used to do for travel deals?
If we confuse the internet, the prices go down. Open up a new browser. Try a new tab. Keep refreshing.
Not working.
Search incognito.
Searching incognito.
I'm scanning the skies for better deals. Try another tab. Keep refreshing. But now Skyscanner makes it so easy to search all our favorite travel sites with one simple search.
Ahí lo tienes, Guille.
Voy a por
Voy para allá. No, llama al lado. Yo creo que sí. Más. Sí, 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 sí. Adelante. Lleva tú. encuentra en el menú. Voy a hacer un cambio de ganancia. Sega. Yo creo que ya no me muevo. Tengo esto de perfil. ¿Y tú puedes enviar eso? ¿Tú puedes enviar eso? ¿O puedes hacer eso? ¿O si es para hoy o ahora o mañana?
Make fast your default. Make safe your default.
Igual me la juego.
cuando voy al tema.
Y ahora cada vez estamos escuchando más clases de movernos.
Cerca de la cara todo. O sea, de cintura para arriba. ¿Has encontrado? Sí.
Un segundo, no me pinches todavía. Vale.
A mí me da igual.
Vamos, niño.
The collection is officially complete. I got it way under market value too.
Hola. Hola. Revístame.
vosotros seguro que tenéis mejor información. ¿Se va a meter la bruma por ahí enfrente? Estaba viendo cómo entra por ahí, por el sitio. Ahí se queda. Se abre la mar. Se queda ahí.
¿Ya va o no? Los cazadores de cistemeres.
¿Están aquí?
¿Quiénes son?
No sé, ¿son estos? No, estos son periodistas.
experience on Earth. Earth is so perfectly positioned to experience this.
Totality hits
this amazing phenomenon that is so rare throughout the universe.
This is a great time to learn more about our own star and how it affects our daily lives.
Instant chills.
I burst into tears.
There's no other feeling like it. It's insane.
Everybody should be watching.
Hello and welcome to NASA's live coverage of the 2026 total solar eclipse. We're at NASA's Goddard Space Flight Center, and over the next hour or so, we'll be tracking the eclipse as it races across the North Atlantic and Europe. A total solar eclipse occurs when the moon moves between the sun and Earth and completely blocks the face of the sun, casting a temporary shadow on Earth. People located within the moon shadow, also known as the path of totality, will experience a total solar eclipse. The sky will darken briefly as if it were dawn or dusk. So weather permitting, people in the path of totality will see the corona, the sun's outer atmosphere, which is normally hidden by the bright face of the sun. Today's total solar eclipse will sweep across Greenland, Iceland, northern Russia, Spain, and a small corner of Portugal. Many other areas in the Northern Hemisphere are already or will soon experience a partial solar eclipse, including much of Canada and parts of the northern US. And for many along the western part of the eclipse path, such as mainland Europe and Africa, the eclipse will occur early evening, creating a rare opportunity to see a sunset eclipse. Over the next couple of hours, we'll be bringing you live feeds from telescopes across Europe and hopefully views of totality in Iceland and Spain. Thank you so much to our partners, Time and Date, Southern Illinois University, and Exploratorium for those views. During today's show, we'll be joined by experts to learn why celestial events like these ones are important to study, document, and experience. And I have an important reminder on that note. When watching a partial solar eclipse, you must always use the right protection. You can use safe solar viewing glasses, like these ones called Eclipse glasses, or a safe handheld solar viewer like this, or you can use indirect viewing methods as well. Regular sunglasses, no matter how dark, will not work and are not safe for viewing the sun. So be sure to stay safe. Now, let's head over to my colleague Ernie Wright, who can tell us more about where the action is happening today.
Thanks, Joy. I'm standing in front of the map that I made for the eclipse that we're going to experience today. We're looking down at the North Pole here, and the red stripe is the path of totality. Those are the locations that will experience totality today. As we animate this, you can also see the much broader penumbra shadow. That's where the partial eclipse occurs. But here comes the umbra shadow. That's where totality is happening, inside that little oval. It passes over the east coast of Greenland, the west coast of Iceland, and across northern Spain, where, as Joy said, they'll experience an eclipse within an hour of sunset, so they should have lots of opportunities for really beautiful photographs. And then as the eclipse progresses and that umbra disappears, West Africa will also get an opportunity to see a partial eclipse as that penumbra shadow sort of slides off the edge of the Earth here. Now, as we zoom up and look at Iceland and Spain, Reykjavik is here in that southwest corner of Iceland. We're kind of crossing our fingers for them because it's a little bit cloudy there right now. That umbra shadow is traveling over 2,000 miles an hour as it passes through the path and crosses the North Atlantic. And then it runs into Spain here, where we expect more than 15 million people will be watching this eclipse. Some of them on the beach in Mallorca right before sunset, so they should get some really beautiful photographs over the mountains to the west. Now, the situation in the US is going to look like this. That yellow line is the southern limit of the partial eclipse. So folks south of that line, you're not going to see an eclipse today. But if you're north and east of that line, you may already be starting to see the partial eclipse. It takes 2.5 hours for that partial shadow to pass all the way across the United States. So it's not like totality. You don't have to run out there at the exact moment. Some places will have a partial eclipse that lasts for almost 2.5 hours. Others maybe just an hour. So this is the situation right now. Montana, your eclipse is over. The shadow is passing out of North Dakota, but Minnesota, Wisconsin, Michigan, you're in it. The Northeast is also in it. And for folks in the Mid-Atlantic, you will be in it soon enough. Now, before you run outside to look at your eclipse that's happening right now, we want to show you a short video about how to observe this eclipse safely.
Meet your new favorite email design platform. Create stunning emails without touching a
Safety instructions and much more about today's eclipse, head to science.nasa.gov/eclipses. So next, I'd like to introduce our first guest here in the studio. We have Dr. Kelly Corrick, who is one of NASA's heliophysicists, who studies the sun and its effects across the solar system. And she's also studied the sun's corona in great depth. Thank you so much for helping us kick off today's coverage.
It's great to be here, Joy.
So let's talk about why we don't always see eclipses on Earth. We've got this awesome model here called an Ori. So using this, can we talk about their orbits and why we don't see it every month?
Yes, so here we have the sun, the moon, and the earth. And as we move, we can see that the moon is not exactly on the same line that we have with the sun. So the earth can view the sun pretty well, but when we get it to about here, we can see that sometimes, maybe a little further, sometimes it lines up perfectly so that we're able to have that eclipse. And that's when we have that eclipse. So that 5 degrees off ends up not having eclipse every new moon.
Okay. And so today's eclipse will travel across Europe for the first time since 1999. Yeah. Can you tell me, why does that region not experience eclipses as often? And what is it that makes this eclipse unique?
Right, so this eclipse is unique because of the fact that A, it's near sunset. It's also the fact that Europe doesn't get as many just simply as to the location, and any place on Earth, really, it's about 300 to 400 years between the time you get eclipses. So there's a lot of ocean on the Earth that it just doesn't go over land. Plus with the angle, it tends to move very quickly and pass in and out, so they don't get a lot of eclipses. And again, it's super special being near sunset, so being able to see a sun setting being eclipsed, it's going to be really awesome photos.
Okay. And I've also heard of eclipse seasons. Can you talk a bit about that?
Yeah, so an eclipse season, when an eclipse happens like this, that lineup means that you're going to see the solar eclipse, so either a partial, annular, or total, and then you're going to see a lunar eclipse about 2 weeks later. So in about 2 weeks, we'll be able to enjoy the orientation where the Earth is actually casting the shadow on the moon and having a lunar eclipse. So that's the eclipse season.
Oh, fantastic. And I know Europe is going to have another eclipse happening in 2027, which seems to be a lucky few years for that region.
Yeah, definitely lucky, and it's going to be a wonderful eclipse, and actually the longest eclipse of the century. So it's going to be 6 minutes and 28 seconds. So that's a very long one. Great for scientific investigation.
Wow. And so eclipses can occur somewhere on Earth roughly every 18 months or so.
Yes.
So why is it that NASA continues to study solar eclipses?
Because every eclipse is a little bit different. The sun changes as it rotates or changes its 11-year cycle. The Earth and the area of the Earth that it covers is different. So we make sure that we study it each time.
Fantastic. Thank you so much, Kelly.
Thank you, Jill.
So throughout today's coverage, we'll be joined by other NASA experts like Dr. Kelly Corrick, who can answer any of your questions that you have about solar eclipses, the science we're doing, and all the other activities you're hearing about today. You can ask your questions in the chat on YouTube, Facebook, Twitch, and Instagram, or tag @NASA wherever you're watching. We also have questions we want to ask you today. So if you want to head over to NASA's Twitch or Instagram stories and take a look at the poll we've got for you, you can participate and answer those questions. And so before we go on, I just want to point out that you may have noticed a clock counting down in the upper left corner of today's show. We'll have 2 different countdown clocks displayed over the course of the next hour that will let you know how close we are to the first instances of totality in the telescope views we have in Iceland and Spain, respectively. Those are the 2 locations where we hope our telescope partners will be able to capture the best views of the sun being totally eclipsed by the moon. We're tracking totality in Reykjavik, Iceland at 1:48 p.m. Eastern Time, or 5:48 p.m. local time, and that will last about a minute or so. And then we're going to set our sights to Leon, Spain, for totality there at 2:28 p.m. Eastern Time, or 8:28 p.m. local time. And the eclipse there will be about 2 minutes long. So there's a lot of science taking place during those fleeting moments of totality today in Iceland, and we have experiments on the ground and in the air. And in the view looking at right now, there's a camera that will be capturing the view of the sun's corona when it's time for totality. When totality hits in Iceland, the planes are going to be chasing the moon's shadow for as long as they can. They're going to be studying the sun's corona, where the skies will hopefully be clear up there. The plane took off from Keflavik Airport about an hour ago, and then we're going to be talking to the science team live from Iceland very shortly. Before we do that, let's learn more about what it's like to be a NASA pilot in those eclipse experiments.
For most people, a total solar eclipse lasts just a few minutes. But NASA's pilots find a way to make it last longer by trying to outrun the moon's shadow with an airplane.
The truth is, it's actually chasing us. We get out in front of it and let it overtake us. Once we're in totality, then we'll advance the throttles to max and try and stay in totality for as long as we can.
Making that happen takes extreme precision. Scientists calculate exactly where the airplane needs to be at each moment.
We do a lot of missions where being in the right point in time and space are critical, and this is one of them.
On Eclipse Day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. That's above most of Earth's atmosphere, where clouds, dust, and water vapor could obscure the view.
Viewing an eclipse from 50,000 feet provides a really clear shot of the sun. And that allows the scientists to have confidence that the data that they're seeing is from the sun rather than distortions from the atmosphere.
When the moon's shadow arrives, it engulfs the aircraft.
It's weird. Right where you're at, it's dark, but everywhere you see is twilight. And the temperature in the cockpit drops, so it's very noticeable.
As the eclipse unfolds, the pilot keeps the aircraft on course, while the sensor operator fine-tunes the cameras, capturing every second of data.
You're very, very, very busy, and it's very high pressure because, of course, there's no do-overs. You only get one opportunity to get all these instruments trained on the right spot.
For the aircraft crew, it's a chance to witness one of nature's most spectacular events while helping scientists better understand our sun.
I'm sitting in the best seat in the house. It's pretty exciting.
Wow, what a job they have today. For this eclipse, the WB-57 aircraft has a camera on the nose of the plane that will be capturing images of the sun's corona. To learn more, let's chat with Principal Investigator Amir Caspi, who is chatting with us live from Keflavik Airport in Iceland. Hi, Mir. Thank you so much for joining us today.
Hi, Joy. It's a pleasure.
So firstly, how are you feeling right now? And can you tell us what experiment you're doing today?
Yes, well, feelings are mixed today because as you can see behind me, the sky is not very great for those of us here on the ground. On the other hand, we have an airplane that's now cruising at 50,000 feet above sea level that's preparing to observe the eclipse in just about 14 minutes. And we are going to be imaging the solar corona with an instrument that has 4 cameras on board with observations ranging from visible light through near infrared all the way to the midwave infrared, which we often refer to as the thermal infrared, to make new observations of the corona and learn all about coronal structure and dynamics.
What is it about the corona, the sun's outer atmosphere, that we're still trying to better understand?
Well, you know, we've known for about 100 years now that the corona is incredibly hot. It is millions of degrees hot, even though the solar surface is only a few thousand degrees. And we're still trying to understand exactly how the corona's magnetic field carries that energy up from the solar surface into the corona to heat it to those high levels. Our observations today will open new discovery space with wavelengths that are very rarely observed, that will allow us to apply physics models to better understand how that corona is heated. We'll also be looking at the structures of prominences or material from lower down that's kind of suspended in the corona that we're still trying to understand, especially in these infrared wavelengths where we don't have a lot of observations. And all of this will also help us to understand, of course, the sources of space weather that affect us here on Earth.
And so I know you flew this experiment and a similar one during the 2024 and 2017 total solar eclipses. What did you learn from those eclipses? And are you making any changes to your experiment for this eclipse?
In 2017, our first attempt at this kind of observation, we didn't even know what we were going to see. And measuring in the midwave infrared revealed new observations and new measurements that I think opened up the possibilities of lots of future experiments to try to better understand this emission from the sun. In 2024, we flew an upgraded instrument, the same one that's flying this year. It has 4 cameras measuring across 9 different wavelength bands. And we learned quite a lot, although we're still analyzing that data. So I don't have any results to share with you right now, except to say that we saw some amazing structures, and it'll be very interesting once we complete our analysis.
Yeah, I'm looking forward.
For this year, we're flying the same... Oh, sorry, go ahead.
No, go ahead.
For this year, we're flying the same instrument, and we're not making any changes to it from 2024, except that we're applying all of the lessons that we learned from the prior flights, including being able to fine-tune the observing time and the observing procedures. And of course, we also now have our data analysis pipeline that's already made from 2024, which will allow us to combine this data with the data from 2 years ago to make new scientific measurements much faster than we were able to do in the past.
Thank you so much, Amir. I know the plane is about to be capturing the eclipse in about 13 to 14 minutes. So best of luck out there, and thank you so much for joining us.
It's my pleasure. Thanks so much.
So let's take a look at the telescope views right now. The partial solar eclipse has just begun in Spain. You can see a little slither of the sun that's been cut off on the one of the sides. The moon has just started to move in front, and will take roughly an hour or so before it completely covers the bright disk of the sun. Thank you again to our partners for these beautiful telescope views of the solar eclipse. We're about 10 minutes away from totality in Reykjavik, Iceland. The telescope views there are cloudy at the moment, but what we're seeing in front of us are views from Spain, and hopefully the skies stay clear for Spain. And fingers crossed, that is what we want for a total solar eclipse, is clear skies. So before totality comes, we have a few minutes to show you different types of science NASA has been conducting in Iceland for years. Iceland is a great place for astronaut training due to its terrain. A few years ago, the Artemis II crew and the science team spent some time there to prepare for the Artemis II mission. Let's learn more.
Iceland is a really wonderful place. It's a great place of interest for geologists, but it's also a wonderful analog. On Artemis, we'll visit the lunar South Pole, we'll make observations from orbit, and we have a whole new set of science questions that we hope that Artemis astronauts will help us answer for the Moon and Mars, which are, of course, planetary bodies we're really excited about for human spaceflight. Specifically for the Moon, we have features here in Iceland that are geologically relevant to the Moon and also just have a sense of scale and a sense of identity that really mimic what we know the lunar surface looks like. There's a reason Apollo astronauts trained here, and there's a reason we're bringing Artemis crew here now. This is just a really wonderful place to learn about processes that shape the Moon and to really understand what it feels like and what it takes to actually navigate and do an EVA or a spacewalk on the lunar surface.
In Iceland, we are doing field work. We're training crew members. This is a key location for training for Artemis crews. Here we see in real time volcanic features that were created not long ago. It's a real special place for doing training for geology.
I'm here in Iceland training the Artemis II crew in geology. There's really transformational science that we can learn by getting boots back on the Moon, getting samples back, and being able to do field geology with trained astronauts on the surface and making observations that only they can make from that perspective.
Everybody start to see maybe softball size, like.
It's a fantastic place here in Iceland to be able to train geology. Also, navigation skills are another big component of what we're doing out here in a beautiful environment like this, out here camping in the highlands of Iceland.
Wow, what an office to work in. So later on in our coverage, we're going to be taking a closer look at the student ballooning experiments as well. And that's been taking place in Iceland for the past 24 hours. But now we're going to be chatting with Marie Henderson, who is the Artemis II Lunar Science Deputy Lead. She has experience training in Iceland and has a key role in the Artemis II lunar flyby data collection. Marie, thank you so much for joining us.
Thank you so much for having me today.
So during the Artemis II mission, the astronauts were lucky enough to see a total solar eclipse from space. Not to be corny, but that's what I call sun and moon joy. Was that something that was planned from your side?
We knew that it was a possibility that we could have a solar eclipse during our lunar flyby. So months before, we prepared our lunar imaging procedures, some of that based on what we learned during the Apollo program, but also some that we learned from imaging that took place during the 2024 solar eclipse. And so we used that to prepare our cameras, but also once we realized we were coming up on a launch day, especially in April, where there was that possibility, we had to go back and we had extra time to train the crew on what they were going to be seeing during this eclipse and what types of observations the scientists were really excited to learn from them for.
Wow, what a lucky alignment of stars.
Yes.
Is seeing an eclipse from space any different from Earth? Did they see different things, and did they have to wear eclipse glasses?
Yes, the crew did have to wear eclipse glasses, and so we got those manifested, as you can see on your screen, for them to make safe observations. One of the large differences between what the crew saw as they went around the Moon and from here on Earth is we looked at an eclipse through Earth's atmosphere, and so they didn't have to look through an atmosphere as they're going around the Moon. So they're able to see the full extent of that corona as well as the zodiacal light in the solar system.
And how long was the eclipse up there?
It's about 53 minutes long. So they got a much longer chance to look at that eclipse.
Wow, what an opportunity. What was the day like for you in the SUR?
It was a very exciting day. This was not something that we really knew exactly how it would be. And so we had just had a beautiful lunar flyby of the illuminated portions of the Moon, and then we turned to watch this eclipse. And the descriptions that we heard coming down saying that they were, this is sci-fi, and they couldn't even imagine, and this glow, we didn't see that in our coverage, but once those images started coming down that night, it was mind-blowing to see. exactly what they're describing. And I wish I was there myself.
Same. Well, that's incredible. So Artemis 2 has just launched, and so we have Artemis 3 to look forward to. Can you tell me how you're preparing for that mission?
Yeah, so Artemis 3 is a different type of mission. We're not going to be going to the moon. We're actually going to be working in Earth orbit. And so this will give us an opportunity to test our human landing systems, which will be the spacecraft that we take down to the surface of the moon.
Should I be nervous about this?
It looks like your SRS airbag light is on. It's best to get...
But we're also going to have an opportunity to do a lot of science at Earth, because this will be a new, unique viewing orientation as well.
Wow, what an exciting few milestones to look forward to. Well, Marie, thank you so much for joining us today.
Thank you so much for having me.
So if you've just joined us, take a look at these maps that we're showing you right now that's showing the path of the moon's shadow. You can see that it's close to reaching Iceland. We're about 5 minutes away from totality in Reykjavik. And over in Spain, you can see that we have about 45 minutes left until totality reaches them. So these are views from Villabado in Spain that we're seeing right now. And if we switch back to the map, you'll see that the moon's shadow actually looks pretty slow as it's traveling across down towards Spain, but it's actually traveling at over 2,000 miles per hour. These maps were made by my colleague Annie Wright. He used various NASA satellite data to create super accurate maps for us. If you want to view and download them yourselves, you can visit science.nasa.gov/eclipses. So now let's welcome back NASA heliophysicist Dr. Kelly Korrick. Kelly, how are you feeling about today's eclipse?
I'm excited for everyone, and I know those clouds are a little worrying in Iceland. That's one of the reasons we had the plane, but also joyful to see the balloons that are going to be launched, as well as seeing it in Spain. So really excited.
Yes, and I'm sure the NASA pilots must be excited as well in the plane.
Yes, exactly. It's a great view. It really is a great view from that.
So here we're seeing a live view from the WB-57 aircraft sensor right now. They're moments away from seeing the moon's shadow hit Earth and also chasing the eclipse. And we haven't actually seen the view of the corona yet from the nose, but they will be capturing images once totality hits Iceland. And on the right-hand side, we're seeing a partial eclipse from Norway, which is really exciting. So we have places across Europe that will be able to witness a partial solar eclipse. There'll be many, many people here that will be able to experience this amazing celestial event. So let's see how many, we're about 6 minutes away from totality in Iceland. Yeah. What do we expect to see right before totality?
Right, so right before totality, we're in that partial eclipse that's going deeper and deeper, and you start to see things go dark. So even if there are clouds, it's going to get a little bit darker. The weather is going to drop too, because again, you've blocked out some of the sunlight, so you're going to get cooler. There's some wind that'll pick up. So the eclipses are really full body experiences. You might also notice that animals react as well. It's not just humans that experience this, but if there are any animals, they might start to pretend that it's nighttime or realize it's nighttime and start to kind of nest. And this is very unique for that part of the world, because right now they're on almost 24 hours of sun.
Of Aragon, for the studies of the physics of the cosmos in Aragon. And this is a center, it's a research center in astrophysics and cosmology, and our main duty is to exploit scientifically and to manage the Javalambre Astrophysical Observatory.
I see, right. Yeah. That sounds fantastic. So now, this looks beautiful, and it's a great place to observe a total solar eclipse. Yeah. But why is it a good place for astronomy in general?
Well, it's a very good place for astronomy because of the skies. We are in a very low population density area in Spain, so the light contamination is essentially null. The skies are very dark, but it's very important that the atmosphere is also very stable, because of the regime of winds coming from an area in which essentially there is no mountains. When the air is coming, the wind is coming, reaching the observatory, essentially is completely laminar. There is no turbulence, and that makes that the seeing how well we can detect or differentiate two different stars, for instance, is great. This is the reason why.
So that makes sense because stars twinkle
Yeah.
because of atmospheric turbulence.
Exactly.
And as astronomers, we want it as calm as possible.
Exactly.
I see. And so this, because the laminar flow is very smooth,
Exactly.
we can see the stars far more beautifully.
Exactly.
Okay, so now what sort of observatory is this? So what sort of observing do you do? What objects?
Yes, our telescopes are particularly suited for doing large-scale astronomical surveys. They are very large field of view telescope. They are very different to most telescopes in the world because we try to optimize first the image quality, but very importantly the large field of view. So our telescopes and the instrumentation that we mount in our telescope are essentially panoramic instruments to map the universe. So we are very efficient in mapping the universe, observing very large volumes of the universe in very short time scales.
Oh,
and that's what makes us very different to most of the observatories in the world.
Lovely. So yes, so seeing a lot of the universe, but very quickly, and so you can map what's going on out there. Fantastic.
Exactly.
Thank you. Now, also, there is interesting future plans, because this is a ground-based observatory with the wonderful mirror, but you have designs, or you're working in collaboration with the European Space Agency for up there.
Exactly. We are also working in the Arrakis mission. Of course, this is a fantastic mission of the European Space Agency, in which we are working here as part of the Arrakis consortium. And in particular, there is a prototype, there is a replica of the Arrakis telescope that is.
When you have everything you need from warm up to wind down, you can give.
The data is not as good as it will be in space. This is obvious because we still have the atmosphere here, even if it's very good. But of course, it has an impact. But we have started to test how the camera works, how the telescope works, how is the data reduction, how we can calibrate. And we are progressing very well, and this is going to be very important so that when the mission is finally launched, everything is ready and is optimal.
Oh, perfect. And that makes a lot of sense, because testing things when they're up in space, if something goes wrong, it's hard to fix.
Exactly.
But doing it on the ground, in this lovely location, it makes a lot of sense.
Exactly, this is why.
Well, it's lovely to see you collaborating with space science, and very good luck with that mission.
Thank you very much.
Thank you for joining us today.
Thank you. Good luck.
Thank you. So that was hearing about sort of what's happening actually here at this observing site. But we've been talking about the magic of the total solar eclipse, the moon going in front of the sun. And when that happens, you can see the glorious atmosphere of the sun called the corona. And we talk about the corona, but let's find out a little more about it.
The eclipse isn't hiding the sun. It's revealing the part of our nearest star that is normally hidden from view. As the moon blocks the sun's brilliant surface, a soft white halo appears around it. This is the corona, the sun's outer atmosphere. Like Earth's atmosphere, the corona surrounds the sun, but instead of air, it's made of electrically charged particles called plasma. Although it stretches millions of kilometers into space, it's normally invisible. The sun's bright surface simply outshines it. This glowing halo is far from quiet. The corona is shaped by powerful magnetic fields. It's also where the solar wind, a constant stream of charged particles, begins its journey through the solar system. When the solar wind meets Earth's giant magnetic field, it can affect satellites, astronauts, communications, navigation systems, and power grids. Despite decades of research, some of the corona's great mysteries remain unsolved. For example, you might expect that the further you move from the sun, the cooler it becomes. Instead, the opposite is true. While the sun's visible surface is about 5,500 degrees Celsius, the corona reaches more than 1 million degrees. For centuries, scientists had to wait for the fleeting moments of a total solar eclipse to study this hidden region of the sun. Today, scientists can create their own eclipses using instruments called coronagraphs, which block the light from the sun's surface, allowing us to observe the corona far beyond the few precious minutes of a natural eclipse. With coronagraphs, scientists began to see the corona continuously for the first time. They discovered it is not a gentle outer glow, but a dynamic and constantly changing environment. This is where the solar wind begins, and where powerful eruptions known as coronal mass ejections are launched into space. Missions like Solar Orbiter are helping us uncover its secrets every single day. But it's still only through total solar eclipses that we get a rare glimpse of this special part of the sun with our own eyes.
So it was lovely to hear about the corona there. And I think we might have the opportunity to go live to Lyon again, just to see what's happening there. So yes, now you can see that the partial eclipse has definitely developed. We have it's like someone's taken a large chunk out of a cookie. And so yes, this is what's happening. We are getting closer and closer to totality. And yes, at the moment we can't see the sun's corona, but when we actually get to totality, that's when it all will be revealed. Now, someone who works studying the sun's corona is Andy Toe. Now, Andy, you work on the Solar Orbiter mission for ESA. So can you tell us, when we actually get to totality, what will we see?
Yeah, we will see something very, very strange and we don't really see very often, which is called the corona, the outer atmosphere of the sun.
Yes.
So this outer atmosphere actually spans millions of kilometers outside of the solar surface, but because the light's so dim, our solar disk is actually about 1 million times brighter than the corona. Yes. So these lights are often overwhelmed by the solar disk. But today, of course, we're seeing this like nature magical moments for us to see the corona for using our bare eyes.
Yes. And so yes, so we'll be able to see it. And hopefully we can see some structure and stuff like that.
Yeah, yeah.
Now, the corona is quite a complicated beast. So this is the outer atmosphere of the sun, the atmosphere of the sun.
Yeah.
But it's not as we expect.
No, there are a lot of open questions and there's still a lot of mystery that we don't understand. Although the sun being our closest star,
yes,
we still don't know a lot of the things about our sun. For example, in the video, we talked about coronal heating problem. What the coronal heating problem is, on the surface of the sun, we have about 5,000 degrees. As we step outside, we get to maybe 1 million, 2 million, sometimes in the extreme case, 10 million degrees.
So sorry, at the surface it's about 5,000.
Yeah.
But then as we move away, it gets hotter and hotter.
Yeah, it's incredible. It's very counterintuitive, right? It's very different from what our daily life experience is.
Yes.
The other mystery that
I was made for more volume, more length.
670, 700 years ago, we started to understand that the sun follows this 11-year solar cycle. What this means is that when the solar cycle goes into maximum, we have a lot of what's called active region. We have a lot of explosions. Some of the explosions are associated with massive blob or enormous cloud of plasma that propagates in the interplanetary space.
Yes.
So,
and some of these blobs of plasma can be the size of planet Earth, I hear.
Yeah. It's absolutely spectacular. And then, especially when flare happens, sometimes particles could travel at a fraction of the speed of light.
Oh.
And also, along with these enormous blob of plasma, this can create what we call space events.
Yes. Now, it's funny because as space scientists, one of the things we are paying more attention to is what we now call space weather.
Yep.
And so it's all associated with this solar wind, these charged particles streaming out into space,
Yep.
and also these coronal mass ejections hitting Earth, because they can cause sort of us challenges here on Earth.
Yeah, they can cause a lot of challenges. For example, one of the obvious challenges is astronomers are some of the astronauts there in space, so they could harm their health. We can affect satellites, navigation system, even transportation on Earth, and sometimes in an extreme case, it can really affect power grid and shut down our power as well. Yeah, so by understanding the sun a bit more, we're trying to kind of find out what caused them, how to predict them a bit better, for us to safeguard the Earth.
Yes. So how is Solar Orbiter doing that?
Oh, Solar Orbiter is doing it in a very spectacular and unique fashion. So Solar Orbiter has a few skills on their hand. One of them is a really, really high resolution camera. So it's able to capture these really, really small scale explosions on the sun that is believed to power kind of the really hot temperature of the corona. The second skill is solar orbiter not only has its camera, it's also a local laboratory. So not only can image the sun, it can also collect particles streaming from the sun to do local analysis. So it can link a process happening on the sun all the way till solar orbiter.
Yes.
So what I think really, really cool and really, really unique is that solar orbiter is starting its orbit. Its original orbit is near the equator.
Okay.
But it's starting to get to a high latitude point where its orbit is doing from flat surface to kind of inclined surface. What this means is that humankind is able to measure and even capture the particles from the pole for the first time. For example, last year, we got some really, really high-resolution images of the pole, which is really, really exciting. And we started to see this really fine-scale dynamics that's happening at the pole. So this is kind of the first time we can piece together evidence seen from Earth and also from kind of an inclined angle to piece out like this 3D structure of the sun to understand how the solar cycle is being driven, what is the 11-year solar cycle, what drives these space weather events.
Yes. So that seems amazing. And I love it that we are seeing sort of more of the sun than we ever have before.
Yeah.
And yes, but it helps us here on Earth by getting better predictions.
Yeah, 100%. Yeah.
Well, thank you so much, Andy, and very good luck with the mission and getting more data.
Yeah, thank you.
Thank you. Now, for centuries, scientists have been looking and using total solar eclipse to understand the sun better. But now we're moving into a new era where we actually create artificial total solar eclipses.
The sun's outer atmosphere, the corona, is usually too faint to see. For centuries, it was only visible during a total solar eclipse. But what if we didn't have to wait for the moon? What if we could create an eclipse whenever we wanted? That's exactly what ESA's Proba 3 mission is doing. Instead of relying on nature, Proba 3 creates its own eclipses in space. Not with one spacecraft, but with two. Flying 150 meters apart, one spacecraft acts as an artificial moon, blocking the sun's bright disk. Meanwhile, the other observes the corona around it. The result is remarkably similar to a natural total eclipse, but with one crucial difference. A natural eclipse lasts at most a few minutes. Proba 3 can observe the corona for much longer. But creating an artificial eclipse in space is no simple task. Even the smallest movement could allow sunlight to spill around the edge of the sun, blocking the spacecraft and washing out the faint corona. The two spacecraft must maintain their alignment with millimeter precision. To achieve this, the spacecraft constantly measure and adjust their position. Their unusual orbit helps make this possible. Instead of staying close to Earth, Proba 3 follows a highly elongated orbit, reaching more than 60,000 kilometers above the planet. As the spacecraft climb higher, they slow down, allowing each artificial eclipse to last for up to 6 hours. Nature gives us just a few precious minutes. Proba 3 extends that moment into hours. And it shows that sometimes the best...
This is called the boundary layer. But during nighttime, when the sun is down, this air stops and it's called boundary layer collapse. So that's exactly the same thing that happens during the eclipse. And we're using these radiosondes to measure the atmospheric changes, the boundary layer collapse, and then the recovery. And we're in Iceland not just because it's in the path of totality, but also its northern latitude and its shorter nights make a completely different boundary layer. So it's been a really cool opportunity to be able to study that under the eclipse, under this unique conditions.
So you're both college students right now. How long have you been part of the project, and what made you want to join the project?
Yeah, so we started this project at the beginning of June. So we've been working with our teams, respective teams, Tessa at the University of Kentucky, and then my team made up of students from across Idaho. And we've been meeting once a week, doing balloon launches, preparing, and really what got me into it was my ballooning club that we have. at the University of Idaho, and we all just, we love the science, we love the teamwork, the team building, and so it's been a lot of fun.
That's great. And so do you have any tips for students who are thinking about joining?
Yeah, so my biggest tip would be to get involved. That was how I learned about this project, was through my club. The professor came to us and was like, hey, there's this really cool opportunity, and so you guys should put an application in. And then also just, if you have internship opportunities and you see those, just put an application in. You never know what opportunity you could get.
And then also, I would say, if you have a class that you're really interested in, just talk to the professor, see if they need any help on the research, because it really gives you a good opportunity to apply your classroom knowledge to real life scenarios, which you don't usually get in the classroom. And you also never know what opportunities will arise, like going outside the country for the first time, like I'm doing right now. So, yeah.
Oh, wow, that's amazing. Well, best of luck. I know you're launching continuously after the eclipse as well. So thank you so much for joining me, Tessa and Jared.
All right, thank you.
So the nationwide eclipse ballooning project are also launching balloons in Spain as well as Iceland, and I can't wait to see their observations. So if we head back to the map, the moon's shadow is heading towards Spain right now, and we're roughly half an hour away from totality in Leon, Spain. For this eclipse, the moon's shadow is roughly 182 miles wide at its maximum width, and it's traveling at over 2,000 miles per hour. And so here we're seeing eclipse views as well in the bottom corner in Leon, Spain. And you can see the little bite that the moon has taken out of the sun. And we can't wait to see totality there. It looks like they have clear skies, which is awesome. And so if you are watching the solar eclipse from the ground, remember to wear safe solar viewing glasses or eclipse glasses, like these ones here. The only time you can take them off is during totality when you're experiencing it. If you're watching the partial eclipse in the United States, you can wear eclipse glasses the entire time. If you want to learn more about eclipse safety, head to science.nasa.gov/eclipses. So total solar eclipses give us a chance to study the sun's corona in greater detail, which helps us learn about how it behaves and affects us here on Earth. The sun is highly dynamic and creates conditions in space called space weather that can affect our technology, from GPS systems and communication satellites and airplanes and even our power grids on the ground. But in order to better understand it, we have a suite of spacecraft that are monitoring the sun from different vantage points around the clock. So let's learn more about NASA's space weather program.
Across our planet, billions of people depend on the invisible networks that connect us to space. Every day, those networks are at the mercy of our temperamental sun and the space weather that it unleashes across our solar system. That's why NASA's space weather program tracks solar storms from the moment they erupt, modeling their paths, anticipating their impacts, and leading the research that the world's industries rely on. NASA's space weather research and modeling is driven by the needs of society and enables critical decision-making that equips pilots to reroute around high radiation areas, farmers to adjust GPS-based precision planting and harvesting plans, and power grid operators to mitigate the impacts of potential surges. For those exploring other worlds, NASA provides 24/7 space weather monitoring for Artemis crews at the Moon and future Mars astronauts who may be exposed to dangerous levels of radiation during solar storms. Whether you're a pilot or a passenger, a farmer or a consumer, a power grid operator or energy customer, a satellite controller or GPS user, space weather impacts us all.
If you're just joining us, welcome to NASA's live coverage of today's total solar eclipse. We're roughly about 24-25 minutes away from hopefully seeing the first instance of totality in Spain. So stay tuned for that exciting moment. And so joining me in the studio now is one of NASA's space weather analysts, Karina Alden. Karina, thank you so much for joining me.
Thanks for having me.
So your role involves monitoring the sun in real time. Can you talk a little bit about what you do?
Yes, of course. So what we do is we basically observe, model, analyze, and then we document it. And so what we're observing is usually those coronal mass ejections, or as I lovingly like to call them, sun burps. And we're measuring those, seeing where they go, and then we're modeling them to see what NASA missions or possible planets they impact. And then from there, we're documenting it and notifying NASA missions about potential impacts.
And so we just learned a little bit about NASA's space weather program. How does monitoring space weather affect the everyday person?
Yeah, so most of the time the everyday person is going to see it in terms of northern lights, but what we do also see is some of that impact to the GPS as you're navigating. Sometimes it'll be a little wonky and you don't really know why, but that could possibly be due to some solar storming happening. And then we may also see some impacts to agricultural folks who are using tractor precision farming.
And so back in 2024, we saw these huge solar storms. Can you tell us how that storm affected Earth and if we had to mitigate any of those effects?
Yes, so along with NOAA's Space Weather Prediction Center, we did have to do some mitigation, but honestly, my favorite part was seeing the northern lights. And so 2024 is when I first got to see the northern lights. I saw them in August, and then you're seeing a picture that I took on my phone where we saw them here in Maryland, which was absolutely incredible. And you can see a picture of the team that I work with, the Moon to Mars Space Weather Analysis Office, along with some of the Heliocomms folks, where we got to see it down here in Maryland, which is absolutely incredible.
Amazing. And so I know that you're also part of the team that monitored space weather 24/7 during the Artemis II mission when we flew astronauts around the moon. What was that experience like?
Surreal. I mean, it's very odd to be staring safely at the sun via satellite imagery, but not see it in person for an extended period of time, because I was working the overnights, but it was incredible, and I loved seeing the solar eclipse from space. I think if I were to do it, I'd want to be one of those astronauts.
Absolutely. Well, thank you so much for joining us, Karina.
Thank you.
So next, let's hear from NASA Administrator Jared Isaacman and Head of NASA Science, Nikki Fox. My colleague Jasmine Hopkins caught up with them a few days ago to talk about why this celestial event is so important and what the 2026 eclipse can teach us about the sun.
Today, I'm thrilled to talk all things eclipse with NASA Administrator Jared Isaacman, who's leading our vision behind science and why eclipses are so important, and Dr. Nikki Fox from our Science Mission Directorate, who will tell us what exactly is going on with the sun during an eclipse. Are you guys ready to talk?
Absolutely.
Okay, fantastic. Our opening question is for both of you. Just a couple months ago, we wrapped up the historic Artemis II mission, and now we're on the cusp of a total solar eclipse. Can you describe in one word how you're feeling right now?
Excited? He took my word.
Okay.
Excited is the right word, because when you saw that total solar eclipse from Artemis II, it was so spectacular and nobody was ready for it, even people who see total solar eclipses all the time. And so when you saw that, it just brought the beauty of space and the beauty of the science we do into such clarity.
I think NASA is one of the only places where we can see a solar eclipse from down here on Earth and then from the other side of the moon.
We study the sun all the time. It's one of our main things that we study in NASA science. We look at it in all different wavelengths. We look at it from all different vantage points to be able to predict when these really large radiation storms are going to come towards our planet, because we want to make sure our astronauts are safe. The eclipse just gives us even more opportunity to study that sun just a little bit more, to really make those big breakthroughs to keep our astronauts safe.
All right, next is for both of you. If you could witness a solar eclipse from anywhere on Earth, where would you choose?
Anywhere that doesn't have clouds. Having been clouded out for the last eclipse, I will say I will go anywhere that there's no clouds.
Look, Iceland is very cool in Spain, a lot of the observation locations for this one, but in Egypt, in the Valley of the Kings, is going to be an amazing backdrop.
And that is going to be the longest total solar eclipse of the 21st century. It is over 6 minutes. To stand in somewhere ancient is particularly moving.
What's the one thing you want people to walk away understanding about why studying eclipses matters?
I think these kind of magical events, I would very much describe that eclipse as a magical event. Maybe it creates a spark in who knows how many people around the world to look up, imagine what's possible, and then grow up and start contributing in this great adventure that we're on.
Remember that Einstein confirmed his theory of relativity using an eclipse. Eclipses are very powerful. You see stars, you see constellations, you see planets that you don't normally see. It kind of reminds you of our place in the universe.
Why do we still care so much about the sun? Is there anything new we can learn about it?
There's always new stuff to learn about the sun. It is our star, but it's the only star we know right now that has the responsibility for maintaining life on a planet. And as we sort of continue to try and answer the question of, are we alone in the universe? Understanding our relationship with our sun is so important, and eclipses give us that opportunity to do that. It is honestly the only time that we can really observe some of the phenomena, particularly down low in the chromosphere, really looking at how the corona turns into the solar wind. It bathes all of the planets, but we live in the atmosphere of the sun. So when you get these big events, they can cause havoc for technology.
Meet the modern parent. Her focus on what matters, laser sharp.
Good to do the surgery.
Understanding our sun is more critical today than ever.
Thank you both so much for being here today. Really appreciate it.
Thank you.
Thank you to our NASA Administrator, Jared Isaacman, and Head of NASA Science, Nikki Fox. Let's head back to Ernie right now, who is going to dive into our eclipse maps and where the eclipse is heading next.
Thanks, Joy. It's so exciting for me to watch this eclipse progress. I mean, we can predict these, but you really can't anticipate how you feel about them until you see them. So I'm standing in front of the eclipse map, and just to recap, this red stripe is the path of totality. Those are all the locations that can experience totality. You're seeing the partial shadow emerge from northern Siberia. It has already crossed Alaska. It's over Canada and the northern United States right now. And that little oval is the umbra where totality is actually taking place. It has just passed by Iceland, and although it was cloudy there, people got to experience the secondary effects of an eclipse where you get the darkening and the brightness along the horizon. And it will very soon be over northern Spain, where we expect more than 15 million people will be watching the eclipse. Toward the end of it, partial eclipse in Western Africa. So this is a close-up view. Reykjavik is here. They unfortunately had clouds, but the WB-57 was flying just above that. And they were there because that's kind of the spot that if you're on the center line, you get the longest eclipse of 2 minutes, 18 seconds today. And we're just a few minutes away from seeing totality pass over Spain less than an hour before sunset. That should produce some really beautiful photographs, especially for folks on the beach watching this over the mountains to the west. This is an unusual eclipse. It's kind of weird. And one reason for that is where the total eclipse starts. This is the Timir Peninsula in northern Siberia. And because they're so far north, that eclipse starts at midnight. They are well above the Arctic Circle, so the sun is up 24 hours a day. And then the other kind of odd thing about it is this north-south path. Most eclipse paths, most totality paths are west to east. But this one, because it's so close to the pole and because of the orientation of the Earth and the fact that it's a descending node eclipse, it's starting in the north and going to the south and then suddenly making this left turn into Spain. So we're looking forward to seeing that total eclipse in Spain where the weather looks great. Back to you, Joy.
Thank you so much, Ernie. So we're about 15 minutes away from totality in Spain. The view we're seeing here is from Leon, Spain. And I want to say thank you again to our partners, Time and Date, Southern Illinois University, and Exploratorium for providing these stunning telescope views of the solar eclipse. This is really, really exciting. They have 15 minutes left until the sun is completely obscured. Luckily, Earth is not the only place you can experience a total solar eclipse. Our astronauts on the International Space Station have witnessed several solar eclipses from this very unique vantage point. So let's learn more from my colleague Abby Unterante, who caught up with the astronauts on the space station a few days ago.
Well, hi, Jessica and Anil. It is so great to talk with you. From the International Space Station, you see Earth and the solar system from a unique perspective every single day. Thank you so much for joining this long-distance call to talk about this moment.
We're so happy to share this with you.
We study the sun and its influence on Earth and throughout the solar system through a field called heliophysics. What is the benefit of studying the sun from up there in low Earth orbit?
One of the big things is that there is a lot of particles that are around Earth, and those particles can be affected by coronal mass ejections, and those ejections can energize the particles and affect things that are in space. And the things that we care about in space are satellites, and those satellites give us communication, they give us internet, and so there's even a future where we have data centers in space, and we're using the sun's energy to power things like artificial intelligence and things like that. And so we need to understand how that's going to be affected by the sun.
If you could pick anyone, who would you want to watch an eclipse with, and would you rather watch it from Earth or
Coronographic?
Yes, because we'll be able to see the corona.
Chronograph the corona.
Yes, because it has a chronograph, and so we'll be able to see the corona.
In fact, it's the moon acting like a chronograph in the natural world. So.
And I think during this eclipse, Miko was talking about getting us
Inspiring me and helping fuel my scientific curiosity and helping me be a successful scientist. It would be to watch that with Jerry, and it would be to watch it from up here, because I know he has never seen one from the International Space Station.
I was going to say something similar. I would love to watch it with my kids because it was such a unique experience for me. When it happened, the animals, the birds got quiet, it got dark, it almost felt cooler, and I think they would really love it.
Sindel, I know you just arrived. Is there anything that you've seen out of the cupola or the wharf that surprised you since you've arrived?
Here's the most surprising thing. On the launch, you have a chance to look out of the window of the spacecraft as it's docking with space station. And when I looked out the right window, I saw this bright, shining thing, the International Space Station. I knew it should be there in space, and we were tracking it, and a lot of people did all the math and engineering to get us there, but it just was something that was just hard to comprehend at the same time, and utterly beautiful. It's this merger between art and science.
The best part about that moment was we were all inside the space station, very anxiously awaiting Anil and Pyotr and Anya's arrival, and we could hear the communications coming from the Soyuz. The Soyuz was, of course, talking to the ground. All of a sudden, we heard Anil's voice, and he said, I see it! I see the space station! It just made everybody smile and made everybody so happy, because we remembered that moment for ourselves when you see it for the first time, and it doesn't even look real. It looks like a little computer animation or something, and it's so small, and then it just gets bigger and bigger and bigger, and then suddenly it becomes your new home.
Thank you so much. It has just been a pleasure to speak with you both. We really appreciate you taking the time.
Thank you, Abby. It's been wonderful speaking with everyone today, so keep looking up, and we'll be waving at you.
So at last report from Mission Control, Jessica, Anil and the rest of the crew had their eclipse glasses on standby, just in case the space station path brought them any unexpected views. So we'll keep an eye out and see if they saw anything. But we did just get something new come in. So a short while ago in Hodgdon, Maine in the US, one of our NASA photographers actually caught the International Space Station flying across the sun during the partial eclipse. Let's take an exclusive look at that image. Wow, that is an incredible shot. So this was taken by Joel Kowski with NASA headquarters. So in the middle, you can see a tiny little speck, and that's the space station that flew right in front of the partial eclipse at 1:14 p.m. Eastern Time. You can see it along the middle here, and there are some cloud coverage. You can see the clouds kind of going in front as well, but this is a really, really beautiful shot. The space station was traveling at about 5 miles per second here, so our NASA photographer, Joel, would have had about half a second to capture this exact moment. In Joel's photographs, you can also see like the slither of the moon at the top corner as well, and the moon was covering roughly 20% of the sun. Although Joel is a very experienced photographer, anyone can take photographs of a solar eclipse. So next, let's hear a few tips on how to photograph one. Sometime after the show, NASA will also be releasing exclusive eclipse images from Spain as well. This is where our NASA photographer, Bill Ingalls, is hoping to capture the eclipse near the horizon. We're about 7 minutes away from totality in Leon, Spain, which is so exciting. This is some of the crowds there that we're seeing. You can see that the darkness is looming. It's not quite totality there yet, but they are almost there, which is awesome. So now I'm joined here by NASA's heliophysics director, Joe Westlake. Joe, how are you feeling about today's eclipse?
Oh, super excited. Super excited to see it and to share our science, NASA science across the world.
So if you're watching from the ground and you don't have eclipse glasses, there are actually many ways to watch an eclipse. These are through indirect viewing methods. So Joe, do you want to walk through some of those methods with us?
Yeah, so these are super cool. This is stuff that you've got at home and things that you can use to help you view an eclipse safely without your glasses. So here we have just a standard colander, right? What you would have in your kitchen. Maybe clean some, berries or whatnot with it. And I'm going to demonstrate how you would use this to look indirectly at an eclipse.
Okay.
You're using the light of the sun as it would filter through this colander. And let's demonstrate together. Here,
okay,
Joy. So yeah, if you could hold that.
Do you need a piece of paper?
You don't need a piece of paper.
Okay.
You can just have it on the ground, something light that you could see.
Okay.
I've got a flashlight that's sort of demonstrating what an eclipse would look like. It's got a little piece of foam there that'll show. So let's shine our light. Let's do our sun, and then show it as it would hit the this colander. And what you can see there is these nice little crescent moon shapes, which are showing the eclipse on our example paper here. So that would usually be a bunch of circles, like if you took this out during regular daylight. Here in the US, you would see just a little sliver gone. Over in Spain, of course, they would see these beautiful little crescent moon shapes.
So you don't want to be looking through the colander, but you want the sun to be shining through it.
Absolutely.
Okay.
Right.
Gotcha.
You want to use this as your light filter for you. And the cool thing is you can use this, but you don't have to use this. There's lots of other possibilities. So you can actually take your hands, right, like this.
Okay.
Spread your fingers out.
Yep.
Hold them over top of each other. And you make little pinholes yourself when you do that.
Okay.
Right? And when you do that, you can actually see through and be able to see the eclipse in the same way, right? So that's a cool way to do it. And then on top of that, let's say you're taking a walk in the woods. Well, the leaves of the trees actually make these kind of pinholes all over for you as well. When they do that, you get this beautiful, constant crescent moons and everything everywhere. One of my favorite ways to see an eclipse.
Thank you so much, Joe. And so today's eclipse August 12th also lands on another special day. So on this day in 2018, NASA's Parker Solar Probe launched into space to study the sun's corona up close. Joe, can you tell us a little bit about that mission?
Yeah, what an incredible mission. This is humanity's opportunity to actually touch our star, right? We flew a mission, Parker Solar Probe. It's still up there, it's still operating, it's still taking great science, but it's flying within the corona, within what you see in the total solar eclipse, and taking direct measurements of that corona to help us understand how our sun works.
Amazing. So we have a lot of questions coming in from social media, and we have time for just one, Joe. Great. So let's dig in. Kyle asks, it seems to be that there are a lot more solar eclipses happening the past few years. Did something change?
You know, nothing changed. The geometry of the sun, the moon, the earth is the same. But one of the cool things about our technological society today is you get to see many more of these things, whether it be because of social media, because of, you know, people have access to cell phones, or just the accessibility of travel and being able to go to these different places. I'm personally really glad that people are hearing more and more about eclipses because it brings the greatness of NASA science home to all of you.
Thank you so much, Joe, for doing this demonstration and for being with us here today.
Thank you so much, Joy.
So now let's head back to the eclipse map where we're going to see the eclipse in real time. So as you can see in the bottom part of this video, the moon's shadow is just about to reach Spain. We're about 3 minutes out from totality hitting Spain. Leon, Spain is going to be experiencing totality, and it will be getting about 1 minute and about 44 seconds of totality, which is so, so exciting. The path is going to be hitting several other towns as well, such as Mallorca and Villalobado. And the view that we're seeing right now is of Leon, Spain. And even though totality hasn't occurred yet, you can see a tiny little filament, or prominence, sorry, on the one side. Okay, so remember to be safe when watching a solar eclipse. You have to be wearing safe solar viewing glasses or use an indirect viewing method when viewing when this moon hasn't completely covered the sun yet. You can only look at a total solar eclipse during totality when the moon is completely blocking the sun. So back in the studio, we have Kelly with us again. Kelly, what is it that makes this eclipse in Europe so, so special?
It really is so special because, again, this is almost at sunset. So we're experiencing something that's a little bit different, having it so low on the horizon. And look at those images there. You're seeing that darkness already coming in, those kind of sepia tones instead of the normal bright light or even the normal types of sunsets.
Wow, so we are 2 minutes away from totality in Spain. You can see the crowds in the bottom corner there, and this is the sun's view. Oh my goodness, so 2 minutes until totality, and we have a sliver of the sun left. This is just amazing.
Yes, it's so beautiful. And like you were saying, there is that prominence there that we already see. So these are things that are very interesting and, again, can erupt in the space weather that we were talking about earlier. So this is a great view. And even with this, you know, it's not complete darkness. That little bit of sun still lights it up so that we can see the crowd.
Wow, so we're about a minute and a half away. What should people expect to see moments before totality hits?
So what they should see is what we call the diamond ring effects, or the Bailey's bead. So these will be really bright lights, and it's from the last bits of sun coming through the moon's valleys. So that will come through, and we'll see that, and you still need your eclipse glasses or an indirect viewing method at that point in time. But then once that's done and you're in the path of totality, it's time to remove those glasses and see the corona with your own eyes.
Wow. And if you're on the ground, what other sensations will you be feeling?
It will definitely be getting colder. There might be a wind. You could, again, change in animal behavior, any wildlife that's around you, and really the sense of awe, as well as the 360-degree sunset all around the horizon. So just a few things to look for.
Wow, this is a stunning, stunning view. We have just a slither left, and this is the moon covering the sun's disk. And when totality occurs, that slither will disappear. We're about 30 seconds away now from totality in Spain. If you're on the ground and you have clear skies, we are so, so happy for you.
Yes, definitely. It's just beautiful, and again, probably feeling so much excitement, and sometimes you even feel a little fear. Like I think was mentioned earlier, they felt it was eerie almost. It's an eerie light. It's not something that we're used to in a human experience. But here it goes. It's we're getting close to those Bailey's beads or the diamond ring effect. So those should be coming very shortly.
Wow. All right. Totality is almost there. The slither is about to disappear.
Oh,
okay.
The little diamond ring.
Wow.
Yeah. All right.
Totality has hit Spain.
Yes.
Oh my goodness.
Lovely view.
What is the red mark that we're seeing on the image right now of the sun?
So the red mark is that filament. So it's a bunch of very hot material that has been hanging above the sun and just kind of hanging out there based on the magnetic fields of the sun that keeps it kind of in a little magnetic cage. Oh, look at that. That's a really nice view of the corona. You're seeing things that look like streaks coming out of this, and those are streamers. So that's the basis of the solar wind that we are bathed in constantly. The sun is constantly outflowing material, and so that's that constant stream, and then you see the what could become a big chunk at some point in time in the pink filaments that you see there.
Wow. So we see that coming off of the sun. So this is the atmosphere of the sun's corona. Are those streaks that you just mentioned, are they coming towards Earth as well?
They are coming towards Earth. So they fill the entire solar system, or the heliosphere, which is actually all that the sun encompasses with that solar wind. So it's the entire solar system, so it definitely hits us here on Earth.
Wow.
And this is absolutely beautiful. Again, you're seeing a prominence also on both sides, really, and maybe even one up on the other corner.
Oh, wow, yeah.
So there's lots of, even though the sun is supposed to be towards a minimum of activity, which meaning you should see less of this, we're seeing more of it. And this is one of the important reasons why to keep studying these eclipses is to see what is actually happening on our sun. When we think we know what's going on, it seems to change it up a little.
And what is it about these features that are so important to study?
It's important to study what they're made out of. Oh, and now we're back to the diamond ring. So we're coming back out of it already. It was always,
wow.
Yes, it happens so quickly. And once you see one, you definitely want to go back and see some more.
Wow. So totality has ended.
Yes.
In Villabado, Spain. Wow. So you're telling me that we also see the diamond ring and Bailey's beads at the end of the eclipse as well?
Yes, exactly.
Wow.
When you're going into or out of the eclipses.
Okay, so this is a view from Valoria La Buena in Spain as well. They are seeing an eclipse right now. Eclipses happening in Spain are about a minute apart from one another in these telescope views. So they're seeing totality. So the red mark that we're seeing right now, is that another prominence?
Yes, those are prominences, that material that is suspended above the sun that's very, very hot. Again, it's interesting to us to know what they're made out of. There's normally filters, like here and on the airplanes as well, to tell us about whether that's some iron or whether that's carbon or oxygen or what exactly is those pink filaments made of.
And you can see the moon is moving away from the sun right now. What is it that we're watching?
Yeah, Bailey's beads, and so these are the beads, and so now we're actually going out of totality again. So
wow, what a brief moment of totality.
Yeah.
This is just amazing. They have had clear skies, and this is exactly what you want for a total solar eclipse. Yeah. Wow. This is Mallorca in Spain. Yeah. Oh my goodness, this is stunning.
Wow, yeah.
Look at that corona. Why is it so much clearer? Why is the corona so much clearer during a total eclipse?
Yes, yeah. So it's so much clearer because you're taking away all the bright light from the face of the sun. The sun is very, very bright. So it's basically 1,000,000 times different. And when you blot out that middle, you can see all the beautiful things that are going on behind it. And so, yeah, so this is the beautiful crescent moon that you're seeing. I think previously we were seeing those strikes of light. That's also closer to sunset there as you go more south in Spain. And already the light's returning, and they seem to be very excited in the crowd there.
Yeah.
It's such a great feeling to experience those eclipses, even though they were so short.
Wow. And experiencing a total solar eclipse, that is completely different to a partial eclipse.
It really is. And it took me, even as a whole heliophysicist, it took me a while for them to convince me that I should do it. And once I saw my first in 2017, I've seen multiple since, because it is a full body experience. It is very different than seeing just one bite out of the moon. The whole body experience and just the joy and awe and kind of your place in the world is so important to experience.
Absolutely. I'm for sure now an eclipse chaser. Well, that was an incredible solar eclipse. What a view. I am thrilled that their skies were completely clear, which means that we could see the sun's corona so clearly. And we could even see multiple prominences as well from the sun, which is a beautiful sight during an eclipse. So in a few minutes, we're going to be speaking with a NASA astronaut live from where they saw a total eclipse. But first, let's go back to the poll that we posed to you earlier on in the show. So, Kelly, I know that you had answered some of those questions as well. Yes. So let's take a look at what our viewers thought about those questions. Okay, so let's head to one of the poll questions. But while we're kind of like waiting to get that set up, let's continue looking at this beautiful partial eclipse now in Mallorca, Spain.
That's just gorgeous. That
chaotic pet energy? Sure. There was once a little guy on high alert.
Sunset. So normally if you're looking at a sunset, especially over water, you're seeing that kind of orange ball, red ball go down, and then you have this beautiful eclipse to happen. These really are just going to be spectacular images.
Yes, absolutely. Okay, so let's head back to the poll answers. Our viewers, so the first question was, where would you rather watch an eclipse from? You said the International Space Station, and our viewers would agree.
Yes, it'll be a party on the International Space Station.
I also wanted to be there too, so we're all going to be up there. The second question on the poll for everyone watching was, what would be your ideal eclipse watching soundtrack? And the options were cosmic lo-fi beats, dramatic space opera music, chill acoustic sky watching vibes, or just the sounds of nature and the crowds. And the winner was cosmic lo-fi beats.
Oh, all right. Yeah, that's a good soundtrack. I can see that.
Yeah. I voted for opera music, but
yeah, and I might be a little bit more sounds of nature, but that's just me.
Okay. Well, anyway, thank you so much. So, although totality is over, the partial eclipse will still be visible for the next hour or so. Remember to stay safe while watching the rest of the partial eclipse by wearing eclipse glasses. Or by using an indirect viewing method. And so if you want to learn more about eclipse safety, go to science.nasa.gov/eclipses. Okay, so next we have a very special guest calling into the show live. NASA astronaut Don Pettit just witnessed the total solar eclipse from Alcañiz, Spain. Don, can you hear me? How are you doing?
I can hear you loud and clear, and I'm standing out in Alcañiz, Spain, just in awe from looking at the totality phase of this eclipse.
Wow, so how are you feeling? I know you just finished watching the eclipse. How are you feeling right now? What did you experience on the ground, and what did you hear? Were you surrounded by crowds at all?
The sky is exceptionally clear, and there's hundreds of people here, and that's part of the eclipse. It's not being off by yourself, it's being with a group of people, the people that live in Alcañiz, the group of people that I'm here with, and experiencing this amazing celestial event all together.
Amazing. So people might know you for your incredible photos and videos from your multiple trips to the International Space Station. Did you take any photos during this eclipse, or did you put your camera down for this one?
Oh, no. What I do is the same thing for launches. You set a camera up on automatic, and you get whatever you get from the camera, and then you stand back and you watch the launch or you watch the total eclipse. They're both kind of in the same category in that they only last a couple minutes in terms of what you could see, and it's better to view them through your own two eyes than through the viewfinder on a camera.
Okay, good tip from a NASA astronaut. So how did the experience watching this from the ground compare to watching an eclipse from space, which I know you've done a few times?
I've had the opportunity to see two solar eclipses from space, And in space, you look at the shadow projected on Earth. You don't look at the sun itself. And the shadow has all the detail that the classic astronomers from hundreds of years ago predicted. You see the umbra, you see the penumbra, you see the shadow moving over Earth, and it's a vantage point from space that you can't see from Earth.
Wow. So lucky. And I know you've seen a lot of other beautiful phenomena in space, like the aurora and air glow. What is it that makes watching a total eclipse special for you?
It's the whole package that comes with a total eclipse. It's the shadow phenomena that happens around you. It's looking at the corona around the sun. It's experiencing the reaction of all the people you're watching it with. So it's a human emotional event as well as much physics and natural phenomenology as you want to add to the mix.
Wow. Well, thank you so much, John. Any parting words?
Just get out and watch an eclipse, whether it's a total eclipse or a partial eclipse. They happen. Lunar eclipses happen. Get out and look up at the sky and think about what's going on and smile.
Thank you so much for joining us live from Spain. We're so grateful you could share your absolutely amazing solar eclipse experience with us.
You all take care.
Wow, Kelly, it's amazing to hear someone as passionate and knowledgeable as John.
Yes, it really is, that he's seen so much and he still is so passionate about the eclipse here on Earth. It just really tells you have to see this thing.
Absolutely. So if you're looking to catch the next total eclipse, you're in luck because we have a few special ones coming up. Kelly, can you run through them with us?
Yes. So next year, there is going to be an eclipse that happens in part of Spain, throughout the northern Africa, through the Middle East. And that's going to be the eclipse of the century, the longest one of the century. So it's 6 minutes and 28 seconds. That's going to be a very long one. And then in 28, we're going to have the eclipse over Australia and New Zealand. So these are going to be great scientific experiments as well as amazing experiences to experience on the ground.
Amazing. And what about the United States?
The United States, well, the next one where we'll have totality is 2044 in Montana and North Dakota, and then 2045. So it's going to be a while before we go California through Florida across the entire continent.
Amazing. So if you want to learn more about solar eclipses and NASA science, you can head to science.nasa.gov/eclipses. So Kelly, thank you so much for joining us in the studio today and answering all of our questions from our viewers. I also want to thank our guests who join us in the studio and on the ground as well, and especially to our telescope partners and everyone who looked up with us here today. And so I think we may have some eclipse pictures from the International Space Station. I'm going to see if we can grab them now for you. If you can't, we'll be releasing them shortly after the eclipse. We're going to be posting them online soon after the eclipse, but yes, we're happy that the space station astronauts were able to see the eclipse from space. So we have something else exciting happening in just a few weeks. NASA's Kennedy Space Center Launch Complex in Florida will become the next launch site for the Nancy Grace Roman Space Telescope. This is a one-of-a-kind observatory that will help answer essential questions about dark energy, exoplanets, and much more about our solar system and out to the observable universe. The launch is currently no earlier than Sunday, August 30th. We're so excited for you to join us next time as we follow another historic mission in space exploration.
Every discovery begins with a new way of seeing. NASA's Nancy Grace Roman Space Telescope will reveal the universe on an unprecedented scale. With its powerful, wide-eyed view, Roman will map vast regions of the cosmos, seek the hidden influence of dark matter, and uncover the mysterious force driving the universe's expansion. With a wider view comes a deeper understanding.